Hey guys, in this lesson we will talk about ion product constant of water. It is represented as Kw. To understand what is Kw, we just need to remember that acids and base react with each other to neutralize a solution. That means acid would always be ready to react with a base because these both together undergo neutralization reaction. We also know one thing, that water behaves both as acid and base because water is amphoteric substance. So if water acts as both acid and base, that means water would readily react with itself, where one of the water molecule is going to behave as an acid and the other water molecule is going to behave as a base. We know water is present in the form of liquid, so the state of water is liquid, and when these two water liquid molecules react with each other, the one that is going to behave as acid is going to release H positive ion to the other one. So one becomes OH negative and the other would become H3O positive. So if H2O is acid, this is going to be its conjugate base, and this base is going to be its conjugate acid. The reason is, if we reverse the reaction, because this is going to be under equilibrium, if we reverse the reaction, then this is the one, OH negative is the one who will take the H positive from H3O positive. So then this is going to become base and this is going to become acid when we go backwards. Now because these are ions, we know ions exist in a state called aqueous, and since this is reversible reaction, so there is a possibility for system to attain equilibrium, and if there is a possibility of equilibrium, there is a possibility to calculate equilibrium constant as well. And equilibrium constant is concentration of products raised to the power of their stoichiometric coefficients. There is one here, there is one here, so these are going to be 1. We put a number or we do not put a number, that will not make a difference. Divided by H2O is given to us in liters. You remember from the previous unit that for equilibrium constant, we do not consider solid and liquid entities. Only gaseous and aqueous entities are considered for equilibrium constant. Therefore, K equilibrium is OH negative ion concentration multiplied by H3O positive ion concentration. The value of K equilibrium is experimentally determined at 25 degrees Celsius. It's specifically at 25 degrees Celsius. K equilibrium is 1 times 10 to the power negative 14. Because this specific K equilibrium is for water, this K equilibrium can also be written as K water. And that's what this Kw is represented as, ion product constant of water. It's nothing but K equilibrium of water. So we know Kw is same as K equilibrium, and the value of Kw is 1 times 10 to the power negative 14. That's always true at a specific temperature, and that is 25 degrees Celsius. We also know that water is a neutral substance. Neutral means its acidic and basic content is balanced out. So OH negative ion concentration is the one that decides the basic content or basicity of a substance, and H3O positive ion decides the acidity of a substance. Because water is neutral, therefore in water the concentration of H3O positive ions and the concentration of OH negative ions is equal. And we know Kw is equal to the concentration of H3O positive ions times the concentration of OH negative ions. Since both of these concentrations are equal, we can write down Kw in 2 different ways. One is, in place of OH negative ions, we can put an H3O positive ion. So it's basically H3O positive times H3O positive. And another way we can write down is Kw is equal to, in place of H3O positive ion, we are going to replace OH negative ion. We know Kw is 1 times 10 to the power negative 14 is equal to, if it is H3O positive times H3O positive, then this can be written as H3O positive square. Therefore, H3O positive concentration would be equal to square root of 1 times 10 to the power negative 14 is 10 to the power negative 14 itself. So we would take the square root of it, and the result will be 10 to the power negative 7. And that is what is the concentration of H3O positive ion going to be? Because this is all happening at 25 degrees Celsius. So this is the concentration of H3O positive ion at 25 degrees Celsius. Because it's concentration, therefore units are going to be moles per liter. Similarly, we can work on this side. We know Kw value is 10 to the power negative 14 equal to concentration of OH negative ion square. When we take the square root of 10 to the power negative 14, we get OH negative ion concentration, and that is again 10 to the power negative 7 moles per liter. This is at 25 degrees Celsius. So from here we know that if we are given a question that is at a temperature conditions of 25 degrees Celsius, and we are supposed to find out one of these two concentrations, H3O positive or OH negative, and the other is not given to us, then the other is automatically 10 to the power negative 7 moles per liter. Let's do a question to understand this concept. Let's say we're given the concentration of aqueous hydroxide ions in a solution of 25 degrees Celsius to be this, and we're supposed to find the concentration of hydronium ions. Always remember, hydroxide ions are nothing but OH negative ions, and hydronium ions are H3O positive ions. Therefore, we are given hydroxide ion concentration to be 0.150 moles per liter, and we are required to find the concentration of H3O positive ion. We know Kw at 25 degrees Celsius is 10 to the power negative 14. Because this condition is not for water, so that's why OH negative is not 10 to the power negative 7. It's for a random solution. But Kw is going to be constant at 25 degrees Celsius no matter if it is water or any solution. We also know that Kw is the product of OH negative ion concentration and H3O positive ion concentration. Therefore, we will substitute the values that we are given. Kw is 10 to the power negative 14. OH negative ion concentration is 0.150. H3O positive ion concentration is what we are looking for. Therefore, we will rearrange the equation to get H3O positive ion concentration, and that would be equal to 10 to the power negative 14 divided by 0.150, which is equal to 6.7 times 10 to the power negative 14 moles per liter. Let's say the question had asked something else, and that would have been to find out if this solution is acidic or basic. How would we do that? In order to find out if a given solution is acidic or basic, we always have to compare their hydroxide ion concentration and hydronium ion concentration. We know that if hydroxide ion concentration is equal to hydronium ion concentration, solution is neutral. However, if hydroxide ion concentration is greater than hydronium ion concentration, solution is basic, and if hydroxide ion concentration is less than hydronium ion concentration, solution is acidic. In this case, we can clearly see that 0.150 is greater than 6.7 times 10 to the power negative 14. So we are in this situation where hydroxide ion concentration is greater than hydronium ion concentration. Therefore, we would conclude that this solution is basic. This is how we find out if a solution is acidic or basic. Let's do another question for the sake of practice. If we have a 1.55 moles per liter hydrochloric acid solution at 25 degrees Celsius, and we are asked to determine the hydroxide ion concentration of the solution, so what are we going to do is, because we are required to find the concentration of hydroxide ions, and we know this condition is 25 degrees Celsius, so we know Kw can be used as 10 to the power negative 14 in this case. So to get this, we need H3O positive ion concentration. For H3O positive ion concentration, we have been given this hint. We know hydrochloric acid is HCl, and HCl is a strong acid that when dissolved in water would give off hydrogen ion and itself becomes Cl negative, and the water is going to turn into hydronium ions. Now we are given the concentration of HCl, that is 1.55 moles per liter. We know from previous grade that when the stoichiometry is same, so this is for 1 mole and this is for 1 mole, the concentration stays the same as well. So 1.55 moles per liter of HCl will give us 1.55 moles per liter of hydronium ions, because it's a strong acid. This is because a strong acid completely breaks to give off H positive ions. Therefore, now we know that the hydronium ion concentration is 1.55 moles per liter. And we are just left to find out OH negative ion concentration. So we can apply Kw formula. And in Kw formula, we have to substitute everything that we are given. H3O positive ions or hydronium ion concentration is 1.55. OH negative concentration is what we are looking for, which is 10 to the power negative 14 divided by 1.55, and that is equal to OH negative ion concentration. And this is equal to 6.45 times 10 to the power negative 15 moles per liter. And this is how we get our final answer for hydroxide ion concentration.